Today we are going to step into another chapter, that is volumes and surfaces of revolution. In this chapter we shall learn how to obtain the volume of solid and also the area of its surface. Okay, we shall learn how to obtain the volume of a solid, okay, by revolving about the axis, okay, by revolving about the axis. So here consider this figure. Let AB be an arc of a curve. Let AB be an arc of a curve, and let CD be a straight line which does not intersect the curve AB. CD is a straight line and AB is a curve, so these two does not intersect, okay, each other. Now draw the perpendiculars AL and BM to the line CD. A solid will be obtained if the region ALMBA revolves about the line CD. Solid will be obtained. Now what is the solid obtained here? ALMBA, okay, about the line CD. So this solid is said to be obtained by the revolution of the arc AB about the line CD. This solid is obtained by revolution of the arc about the line CD, that is the x-axis. About the line CD. The line CD about which the curve rotates is called the axis of revolution. Once again I am explaining here. Let AB be an arc of a curve and let CD be a straight line. Now draw the perpendiculars AL and BM. CD be a straight line which does not intersect the curve AB. Okay, now a solid will be obtained if the region ALMBA revolves about the line CD. This solid is said to be obtained by the revolution of the arc AB, curve AB about the line CD. The line CD about which AB, curve AB rotates is called the axis of revolution. This line CD is called the axis of revolution. The line CD about which the curve rotates is called the axis of revolution. Now coming to example. Now find the volume of the solid obtained by revolving the ellipse x square by a square plus y square by b square is equal to 1 about the axis of x. So the ellipse is defined by, we all know that equation of ellipse is x square by a square plus y square by b square is equal to 1. So now this is the ellipse, okay, this is the origin, this is the x-axis, this is a dash and b dash, okay. When the ellipse is defined by x square by a square plus y square by b square is equal to 1 when rotated about the x-axis. Now isolate y square from the ellipse equation. First step to find the volume of the solid obtained by revolving the ellipse about the axis of x. First step, you have to isolate y square from the ellipse equation. So the equation of the ellipse is x square by a square plus y square by b square is equal to 1. Now we have to isolate, means you have to separate, okay. X square by a square minus 1 is equal to minus y square by b square. So now 1 minus x square by 1 minus x square by a square is equal to y square by b square. If you take minus, if you multiply this with minus, minus into minus will be minus, into plus will be minus, okay, and minus into minus will be plus. 1 minus x square by a square is equal to y square by b square. So now here y square by b square is equal to 1 minus x square by a square. So y square is equal to b square into 1 minus x square by a square. Now the second step to find the volume of the solid is set up the integral. So the volume V is found by integrating along the x-axis from minus a to a. Now we have to integrate along the x-axis from minus a to a. Okay, so V is equal to pi so the volume is V is equal to pi integral minus a to a y square dx. After isolating, now we have to integrate along the x-axis from minus a to a. A is the upper limit and minus a is the lower limit. Okay, pi integral minus a to a. What is y square here? B square into 1 minus x square by a square dx. Okay, now we have to integrate. Volume is V is equal to pi integral minus a to a b square into 1 minus x square by a square dx. Now the third step to find the volume of the solid is integrating now. Now pi integral minus a to a b square 1 minus x square by a square dx. So here as we know, integral a to b f of x dx is equal to f of b minus f of a. Okay, now if you apply the lower and upper and lower limit, okay, so if you apply the upper and lower limit, what do you get here? F of b minus f of a. Now similarly here also pi b square, taking this b square outside, integral minus a to a 1 minus x square by a square dx. Integral, now we are finding this value, this particular value here, integral minus a to a 1 minus x square by a square dx. So integral minus a to a 1 dx. Okay, now separating the terms, okay, individually we are going to integrate here, minus integral minus a to a x square by a square dx. So as we know, integral 1 dx is x. Okay, now applying this upper and lower terms, minus a to a. Okay, after writing down the integral value, we are going to, after integrating the function, we are going to apply the upper and lower limits. Minus 1 by a square, taking this constant outside and only integrating only the x term here, integral minus a to a x square dx. Okay, so x minus a to a minus 1 by a square. So if you integrate this integral x square, you will get x cube by 3. So 1 by 3 integral minus a to a x cube, okay, dx it will be. So minus 1 by a square into 1 by 3 x cube minus a to a. So now applying the upper and lower limit here. So as we know here, when you apply upper and lower limit here, how are you going to apply the upper and lower limit? Upper limit minus lower limit. Okay, so a minus of minus a plus a, minus 1 by 3 a square, a cube plus a cube. Okay, minus of a cube you have to apply this upper and lower limit a cube. Okay, minus of minus again, so minus of minus is plus plus a cube. Okay, minus 1 by 3a square a cube plus a cube. So a plus a will be what? 2a minus 1 by 3a square. Now a cube plus a cube will be what? 2a cube. Okay, 2a minus 2 by 3, this a square and a cube. Okay, you will get here 2 by 3a. So 2a, if you take common here, you will get 1 minus 1 by 3. 2a, now if you solve this, you will get 3 ones are 3, 3 minus 1, 2 by 3. Okay, so 2 into 2, 4a by 3. 4a by 3, right? So, as we know here, now we have found this particular integral value. So what? So is equal to pi b square. We all know that. Now we have already found. Now we have found this value. Now we have to substitute that value here. So pi b square into integral this value. So how much we got here? 4a by 3. Pi b square 4a by 3. So 4 pi ab square by 3. 4 by 3 pi ab square. I'll once again explain the integration here. So here integrate, okay, pi is equal to pi integral minus a to a b square 1 minus x square by a square dx. Okay, we know that integral a to b f of x dx is equal to f of b minus f of a. Okay, pi b square integral minus a to a 1 minus x square by a square dx. Now we are finding this particular value. Isolate this now. Now let us find this value and then multiply with this to get the final answer. Integral minus a to a 1 minus x square by a square dx. So integral minus a to a 1 dx minus integral minus a to a x square by a square dx. So integral 1x is x minus a to a minus 1 by a square integral minus a to a x square dx. So x from minus a to a minus 1 by a square into 1 by 3 x square. If you integrate x cube by 3, so 1 by taking this 1 by 3 outside, 1 by 3 x cube, applying this upper and lower limit. Okay, minus a to a. So a plus a minus 1 by 3a square a cube plus a cube. So a plus a is 2a minus 1 by 3a square 2a cube. 2a minus 2 by 3a. Now 2a, if you take common here, 1 minus 1 by 3. 2a into 3 ones are 3, 3 minus 1, 2 by 3. 4a by 3. 4a by pi b square, 4a by 3. 4 by 3 pi ab square. Okay. This is v. V is equal to 4 by 3 pi ab square. So this is the volume of the solid. So this is the volume of the solid obtained by revolving the ellipse x square by a square plus y square by b square is equal to 1 about the axis of x. So we all some important points regarding this problem. The equation of the ellipse is x square by a square plus y square by b square is equal to 1. Okay. Now to find the volume by revolving the ellipse by revolving the ellipse about the axis x-axis, we have to first isolate y square, okay, from this equation, from the standard equation of the ellipse x square by a square plus y square by b square is equal to 1. Then what we have to do is we have to now we know that volume is defined by v is equal to pi. Since it is x-axis, v is equal to pi, and x-axis we have to integrate this y square from minus a to a. So v is equal to pi integral minus a to a y square dx. Okay, then after isolating y square, the value which we got, we have to substitute in the place of y square. Then we have to integrate this. After integrating, the final answer we will get as v is equal to 4 by 3 pi ab square.